So now that n equals 1 time series analysis has told us that we have 4 possible random effects, right? And we're going to utilize that understanding in our analysis of all of the smoking data subjects and allow for parameter variation across the subjects using random effects. So random effects sort of sounds like a statistical term. Random sounds like haphazard. All we mean by that is that parameter values differ across individuals, across subjects. This is then doing the analysis that Ellen talked about this morning. She talked about 2-level analysis the whole morning. So I'm going to start where she went, what she was working with. I'm going to start that and then take it a little bit further in terms of trends and cross-classified analysis. But first I want to do the 2-level analysis. And you see then right away that my pictures are a little bit different than hers. This describes the model on the within level. Below here would be the model on the between level with all the circles, the continuous latent variables representing random effects. But I want to focus on the within level, the dynamic part. Like Ellen, I choose these filled black circles for the random effects. The random intercept sitting at that box, the random slope phi or phi, the random residual variance without headphones, and the random slope for smoking urge on negative affect. I draw it for 2 time points. I draw it this way, full well knowing that this is not exactly the model that's analyzed behind the scenes. That is, you have to know then that what's really done on the within level is to do this regression for the within level latent variable centered component of the total variable. Ellen had a very nice way of representing that, where you did that decomposition into within and between latent variable parts from the observed, and then she showed the model for the within parts up here in terms of circles. That's one way of doing it more completely. And in the Mplus Users Guide, for example, 9.30, I did it yet another way. And actually, I think you saw, Ellen showed that one too. But when you get more and more complicated models, I think this simplistic approach can be useful to describe it pictorially in a simple way, even though you have to then take into account that it's not totally faithful to the modeling. So we have 4 random effects here, and you can ask, what do we do with these guys? Well, you should think of them in the first round. You should think of them as x variables in regression. We never specify a model for the x variables. Well, you do maybe now when you've heard about bringing x's in to handle missing data. But typically, the x variables in regression, they don't have parameters that get estimated in the regression analysis. You estimate alpha, beta, intercept, slope, and the residual variance. You get the variances, covariances, correlations among the x variables from sample statistics outside of the model. Same thing here. Except when you have missing data on this, and we're going to see results of that, then you may want to bring it into the model. If you bring it into the model, maybe you do want to have auto regression also for that explanatory variable. And once you're into that thinking, why don't you think that negative affect at the previous time point influences the smoking urge at the next time point for a substantively meaningful time difference? It could be that when you were irritable here, it led you to smoke then. Or you can have this going down like that. I actually explore that. Smoking urge does not tend to influence negative affect, but negative affect tends to influence smoking urge. But of course, you could have the full model like this. So there you have the cross-lag model that Ellen talked about in this smoking example context. I'm going to stick to this model. This is the model that I'm going to choose to specify the input for. And what do you have here? Just repeating what we learned this morning to emphasize it. You have your use variable list. and you have to smoking urge, negative affect, and we're going to relate that to age and female. We, like in regular two-level analysis in Mplus, we declare what the cluster variable is, what the variable is that describes what cluster you're in, and that's going to be the variable subject, which sits up in the data set up here. Between variables are female and age, between meaning variation across subject. And now we're going to declare negaf as a within variable. By that, Mplus mainly means we're not going to try to model variation across subjects in negative affect separate from the within variation. In fact, this is going to be the whole observed variable that we're going to work with. And if I just go forward to the next slide, we work with the whole variable here in the regression of urge on negative affect. Just like in regular multi-level modeling, if you do HLM, for instance, in Raudenbusch and Breich style, when you have a random slope, it's for the whole observed variable. And however, Raudenbusch and Breich also then, in the random slope situation, recommends to do cluster mean centering of that explanatory variable. And that's what we do here. Center by group mean the negative affect variable. So we get rid of, we don't want to confound within and between matters here, as Ellen so eloquently described. We have lagged for both urge and negative affect because we have both those arrows drawn. If we wanted to, we could also have the cluster mean version of the negative affect as a explanatory variable on level 2. We're going to leave that aside. Two-level modeling is done, and random is added because we want to have a random slope. And then this is sort of standard for me now. B iterations, two processors are the two chains going forward in the trace plots, and that's what the PSR convergence criterion describes when they start moving in tandem. I always use B iterations at the minimum number of iterations that I want to use, and but sometimes then Mplus goes further because PSR did not go down to 1 in only 1,000 iterations, but it goes further and say it stops at 1,500. Well, then I want to go on to much higher, maybe require B iterations 5,000 to see the PSR close to 1 for a long stretch of iterations. So the model then is on within and on between. You have the random slope, phi or phi, that is the auto-regressive coefficient with lag 1. You have the random variance, in this case it's for the dependent variable, so it's the random residual variance. You have the random slope in the contemporary or concurrent regression of smoking urge on negative affect at the same time point. And then we add this negative affect on negative affect time period previous for reasons that we want to we want to be able to bring in negative affect into the model because it has missing data on it. Timur, do we have to say neg f here to bring it into the model? Is Timur here? While he thinks about that, I'll just describe the between level. So then you have the smoking urge, the intercept, random intercept, the random phi, the random residual variance, the random slope, regressed on the between level variable female and age, and you let the residuals be covaried because there are probably many other variables that influence them than female and age. And what's the answer, Timur? It's negative, yeah. So it's already brought in as a dependent variable by that statement.
Right.
Yeah. So you don't have to do anything further. So you can have missing data on negative affect here, and no problem. Yeah. Okay. You can see this is all still very new for us. And then in the output, we're going to ask for Tech 1 because Ellen loves Tech 1. And we're going to ask for Tech 1 because Bengt loves Tech 1, Tech 8 rather, I should say. And we're going to do a factor score comparison. And when we say factor score, FS, we mean random effects. It's the same thing. Anything that's latent and continuous, it's a factor score in our words. If it's a factor, yes. If it's a random effect, yes. If it's a growth factor, yes. If it's a trait in IRT, yes. It's a factor score comparison. Going to see what that looks like. As for standardized in the fashion that Ellen described, within person standardization, Tech 4, that is the mean variance covariances among the latent variables and residual. And we're going to plot, and we're going to do plot, have available for the plot factors, all of the factors, and all of the random effects. This two-level regression takes almost 4 minutes. If we drop this, bringing in the factors into the plot, it goes down to 3.13 minutes. And this is a feature or part of the program that we might try to speed up, so those two are less different. Here are the results. And here then you see the between-level model plotted. And where we have these background variables, that I described as W before. And we have the 4 random effects here. So it's an interesting regression. The dependent variables are all unobserved. How can you do that? It's statistical magic again. So anyway, you have the effects then of female and age onto these 4, and the only significant ones are the ones that have a negative and a plus sign here. So this says that females, relative to males, conditional on age, have a lower autoregressive coefficient. Lower. So that's different from negative affect, where females tend to have a higher in research, but in smoking urge tends to have a lower one. And the residual variance, however, and therefore the whole variance of smoking urge, is higher for females. We're going to see what the consequences of that lower phi and higher log V are for females when we bring in distal outcomes over here. But for now, we're just saying these are the results. And an interesting finding, that I don't know how general it is, but phi on female being significant here happens only because we allow log V and SYX to be random. I'm saying this backwards to what the text is. Maybe that's confusing. So it's not significant unless both log V and SYX are allowed to be random. So that sort of speaks for including a lot of random effects, which may or may not be causing problems because of other matters that we're going to discuss.